recording now. So today, what we're going to do is we're going to talk about functions going from equations to tables to graphs. And really, this is sort of the order that we'll go in, is to start with this and work our way this way. You can go in other directions, but I think this is the one that shows how they all connect when we do this. So what I want to start with is I want to start with a very simple equation for us to be able to use. So what we'll do is we're going to talk about the equation. So I'm going to give you this as an example to start. And what we are going to do is, remember, we've got our input is our x. I'm going to label this one as an f, so that's the name for the function. And I'm going to make this as easy as I possibly can. We're going to have this equation just be x plus 2. So our whole equation is we take the input value and we add 2. That's all we're doing for our equation, okay? So here is what we do to be able to take an equation and use it to make a table. So what I'm going to do right now is this. I'm going to make a table right over here with an x and a y. And I'm going to do this. I'm going to make sort of a line to show you this is sort of dividing from one to another. And what I'm going to do is this. To be able to go from an equation to a table, all you need to do is to pick some input values to choose. And so I'm going to choose, let's go with 5 of them because I think these will be easy. And I'm going to use different colors to sort of show us what it is that we can do with this for where things are going to be. Now, I got to pick 5 colors, so give me just a second to kind of get through this for a minute. And then we'll do this. All right, so I've got my 5 colors. So what I'm going to do, let's go with, we will start with 0, and then we're going to do 1, 2, 3, and 4. Now, these are our input values. And so what this means is this is what we're going to plug into this function to get our output value. So this is kind of how this works. What you do is for each of these, what we're going to do is we are going to plug in this input. I'm going to take this input and put it right there. So this will be f of 0. And then what I'm going to do is use my rule that we have right there. I know that it's going to be something plus 2. So all I'm going to do is just instead of x, I'm going to replace it with that. So this is the way we use the equation. This is our equation, and we just plug these in. Now, 0 plus 2, well, that's just equal to 2. So that's the answer for that one. And then we do this for all of them. So what I'm going to do here, I needed a little bit more space for this because I've got a total of 5 of these. So I'll make sure we can kind of have the space for it. And for all of them, the rule is the same. We're adding 2 to whatever we get here, okay? So when I do this, I'm going to do the same thing with 1. F of 1 is 1 plus 2, which is 3. So that'll be my output, my y value. And then I'll put in the 2. When I plug in the 2, 2 plus 2 is going to give me 4. So 2 goes to 4. Then I do the same thing with the 3. 3 plus 2 is 5. And then I do that same thing, plugging in the 4, and 4 plus 2 is 6. Now, these are great because we just had to plug them in and they all go in an order. You could plug in anything, but it should be able to follow the same pattern. Now, what we want to do then is to take this and go to a graph. Well, all we need to do then is to take this and take all of these points right here and graph them. Now, I'm going to use graph paper to be able to kind of get us to what we're going to need. And I'm going to fold it in half so that I can use this a little bit more sparingly. So give me a second. I'll make sure that it fits where we need it to go. So this is where we're going to graph each of these points. Okay. Now with this, I'm going to use the same colors that we have here just to make sure we're kind of using the same things. But what we have to remember is that when we're doing this, this tells us an X and a Y. So that's our X and our Y. This is where we're going to go. So we start off with 0, 2. So 0 is X, 2 is Y. So that's right there. Then my next one is 1, 3. So I go over 1, up 3. There's that. And then the next one is 2, 4. I go over 2, up 4. I think we've kind of found our pattern here. Then over 3, up 5. That will be right there. And then the last one will be over 4, up 6. Okay, so right now, how would you describe that graph? What does that graph look like to you? Somebody write it in the chat. What does that graph look like? It's a line. You're right, Stephen. So when we look at something like this, what that means that we're going to get in a lot of these cases is we chose these 5 input values, got these 5 output values, and we graphed them. This is absolutely a line. Now, what we know is I could pick more. And this is enough information to tell me, okay, we know what the pattern is. If I connect these, this would keep going all the way up in that pattern up that way and all the way down this way. So that if I wanted, I could plug in any of these values. If I plugged in -4, I would get out -2. If I plugged in -7, I would get out -5. So any point on this line follows this original rule. But this original rule to a table, we only did these 5. So a lot of times what we're doing when we start with an equation and we get a table is we're giving ourselves a pattern and then we extend that in each way. That's the reason why this line keeps going as we do that. So does that make sense with what we're trying to do here? Is this okay for everybody? Does everybody understand this? Give me a plus if you get it, and a minus if you do not. So I got a plus there. Who else has got a plus for me? Thank you, Stephen, for voting. Because I'm going to try to do this a couple more times just to show you how this works. But really, this is how we create these graphs. And because there's an equation that can give us more points, that means that whatever pattern we see here, we can keep going with if I plugged in more. Like for instance, if I tried to do here, I'll just use a number. We'll say, let's say I did 7. I know that the 7 plus 2 is going to give me 9. So if I went over here and did 7, 9, there's 7. 9 is right on that same line. So anything that I would pick here should be on that same line as we do for the pattern. Okay. All right. Let me give you a different one because we've worked with lines before. And I could do a couple other ones, but I want to show you how this works with more than just one thing. Okay. So what I want to do is to show you how we would do this with maybe a little bit more of a complicated one. So I'm going to do again, I'll give you the same 3 things. We will do equation, table, and then the graph will be over here. And so I'm going to, I don't want this to be difficult. So we're going to start with, we'll call this one g of x, because remember, we can call it different names. And this is going to equal, I'm going to do x squared for this one. Okay. So when we do our table, it will be an xy, just like we did before. And I'm going to have to pick some values to plug in. And I'll do 5 again, but I'm going to do them a little bit differently. I'm going to go +2, +1. I'm giving myself a little bit of space so I have some space for work. 0, and then I'm going to go with negative numbers. -1 and -2. So we'll do the same colors that we did before, But let's do this same thing. Now, when we're doing this, whatever I plug in, I have to remember taking that thing and raising it to the second power. So I'm going to write this for all 5 of them. I'm going to write this so we have a space to put it. This is my function frame. This is where I plug my input values into. And I'm going to make sure that we have this in a space for us to see. So we can do all 5 of these, and then we'll see how this looks on a graph, because the graph sometimes gives us better information than even looking at these numbers. Okay, so we'll do one at a time. Do you guys remember when I square something, can somebody tell me, what does that mean I do? Does anybody remember that? So if I do, so I'm plugging in the 2, and it's 2 squared, what's the math that's happening there? What does 2 squared mean? If I plug in a 2 here, does anybody remember? What does 2 squared mean, or 2 to the second power? Kwong, you're right, it is 2 times 2. It means multiplying times itself. So 2 times 2, that's going to give me a 4 as an output. Okay. And we're going to just keep doing this in the same way. So if I plug in the 1, 1 squared is 1 times 1, which is equal to 1. Okay. And then I always like using 0. It's normally easy. 0 squared is 0 times 0. And anything times 0 is just 0. 0, 0. Then we have -1. And this is where things get a little bit different. -1 times -1. What does that equal? If I do -1 times -1, what do I get? Does anybody know? -1 to the second power, or -1 times -1? Kwong, you are right. It is a +1 as an answer. So that's what I'm going to get out for this one. And then we'll do the last one here with the -2. And what we have to remember is if it's -2 times -2, a negative times a negative is a positive. So -2 times -2 is going to give me a +4. Now, this is going to be an interesting graph, because what we should be able to do is see where everything is when we're done with this. So let's see how this works. We're going to start with 2, 4. So I go over 2, up 4. That's going to be right here. Okay. Then 1, 1, over 1, up 1. Then I have 0, 0. Okay. It's right here. Then I have -1, +1. So I go left 1, up 1. And then I'm going to have -2, so left 2, and then up 4, like this. Now, if I connect what I have so far, this looks like it's kind of got a mirror here. And this is kind of shaped like a U. Now, a lot of times what you'll do is just kind of put a little arrow on each side here to say it keeps going. But if it does that, I can actually tell you that the next one on each side is going to be a 9, because that's what 3 times itself is. So if we look like this, sometimes we'll get a graph that looks a little bit different, but we can keep going and seeing what happens. In this case, does anybody remember what the name of this graph is called? It has a very specific name, and I wanted to see if you guys could remember that. Starts with a P. Anybody remember? It is a U shape. You were right. It is. We had these called as a U shape. This is called a parabola. Now, here's the thing. Is there one like f of x equals -3x plus 5? You have just given me my next example. There is absolutely one like that. And actually, here's the thing. As long as there's a rule with x for this, we could do anything. And I mean literally anything. I could do anything with the math stuff here. As long as I'm plugging in values, I can get values for a table, and I can make this table into a graph. Let's use your example, Stephen, and see what happens when we do that, because what we'll find is that they kind of fall into different patterns, and that's what I want us to be able to do. So let me do that one. Give me just a second. I'm going to try to prepare my graph thing. I think I've done a pretty good job of having this set up, but like sometimes using the pieces of paper gets a little bit messy here. So let's do that. Let's start off with f of x equals negative 3x plus 5. Okay, and for this one, let's do this. With something like this, a lot of times with these, I'll start at 0 and work my way down. But if we're going to do that, let me make the table. So I will do the XY table here. And the values I'll put in there. And guys, I tend to choose numbers that are right next to each other. So like 0, 1, 2, 3, 4, 5, or 0, 1, 2, 3, 4 is fine. Or like when I did that -2, -1, 0, 1, 2. Try to keep them close to each other so that we can recognize a pattern in the graph. So let's do the ones that we had done before. So let's do a 0, and then we'll do 1, 2, 3, and 4. All right, let's see what happens. I'm going to make the frames for each of these. So f of blank is equal to, now when I do this, I do have to remember that I've got more than just one work thing to do here. So before I just added 2 or then I multiplied it by a number, you got 2 spaces for it. So you want to make sure that you have the space for that in each of these cases. And I'll do this for all 5 of them. And one more. Okay, so let's put these in here. So the first one we're going to put in is the 0 right there. Replace the 0 here. And I'll show a little bit of work below because I think it might be easier. So -3 times 0 is 0 plus 5 is going to give me 5. So 0 goes to 5. All right. Then I'm going to plug in the 1 here. And I can't do the arrow in the same way because I've done a little bit of work below, but I think we're okay. -3 times 1 is -3. -3 plus 5 is a +2. So 1 goes to 2. Then I'm going to do the 2 plugged in. -3 times 2 is -6. Plus 5 is going to equal -1. So that'll be right here. Then I'm going to do the 3. Plug in a 3 here and here. -3 times 3 is -9. -9 plus 5 is equal to -4. So that'll be here. And then for my last one, f of 4, -3 times 4 is -12 plus 5 will be -7. Now, I want to show you something. And it's not hard. You're just doing the same math that we always do. In this case, all I'm really doing is just plugging these things in and doing this work. But I want you to notice really quickly, every time this one goes up 1, the pattern is that this one goes down 3. 5 to 2, that's -3. 2 to -1 is -3. -1 to -4 is -3. -4 to -7 is -3. So we do have a pattern here that we could use. When I graph this, all I'm really doing is just doing the math. But I'm going to show you something really quickly. When I do this graph, let's graph these real quickly. So we've got 0, 5. That's going to start right up here. And then we've got 1, 2. So over 1 up 2. And then we've got 2, -1. All right. And then I've got 3, -4. And then I've got 4, -7. Okay. What type of graph is this, guys? What have I drawn? What does this look like here? It's a line. It's clearly a line as well. I want to show you something cool about this. We haven't talked about this in a little while, but we know the equations of lines, right? If we look at this, we have a slope and a y-intercept. And it's been a while since we've talked about those, but if we look, our y-intercept is right there at 5. And our slope, if we look at it, we go down 3 and over 1, negative 3 over 1. So that means that our y-intercept is 5. Our slope is negative 3 over 1, which means our equation is y equals mx plus b, or y equals negative 3 over 1x plus 5. Now I want to show you something. If you look over here at the original equation, negative 3x plus 5, negative 3x plus 5, we've already done this. We did this earlier this year. We just didn't go through and go from this to a table to a graph. Sometimes you learn shortcuts that let you go directly from the equation to here. When we know that it looks like a line equation, we can jump to this and say, oh, well, if I've got negative 3x plus 5, well, then I already know the y-intercept is 5. I know the slope is negative 3 over 1, so I can graph it. So what this lets you do is sometimes you can skip the table to get to the graph. So we know a lot about lines. Let me give you another equation that's like a line. And let's say our equation instead will be f of x is equal to, let's go 1/2 x plus 3. Now, right now, what I want you to know is that when we do this, this is just like y equals mx plus b. That's our slope. That's our y-intercept. So if we want to, we can use what we remember from that and graph these things. That 3 is our y-intercept, so that can be on the y-axis right there. And if that slope is 1 over 2, what we have to remember, that top is our change in y, so that's up 1. This bottom is our change in x, so that's over 2. So I can keep graphing more points, up 1 over 2, up 1 over 2. And if you notice, it's just like what I did when I made the table. And that's exactly what we would do for this, is that if I was plugging in values into a table, if I plugged in 0, I'd get 3. If I plugged in 2, I would get 4. If I plugged in 4, I would get 5. And that's the way that we go about doing this. Sometimes we know enough about the equation to skip steps and go directly to the graph. But when you get things that are not as easy as that, that's when you can use the table to make sure that you understand what to do. Okay, so I have a question, guys. I have sort of shown you the general idea of how we go from equation to table to graph. I've shown you how we can skip that step if we know enough about it. And you're going to learn more rules in Algebra 2 that'll help you go to this other side. But are there any questions that you guys have about how this works today? Any questions at all? Well, thank you, Stephen. I appreciate that. What I'm going to do then, I think I'm going to stop the recording